Alright, so for the motor control portion of the course here, we're going to be hooking up some forward reversing motor starters in some different ways. And I just want to do this first introductory video to kind of walk you through the pieces of a forward reversing motor starter and how to identify the contacts on the forward reversing motor starter and a little bit about what they are. I use this antique GE motor starter just because everything's nice and out in the open and you can see it. More than likely you're not going to hook one that looks exactly like this up, but the parts and the functions of them are all basically the same. So the first thing I want to point, so to start out with, in order to have a forward and reversing motor starter, we're going to have a forward coil as well as a reverse coil. And what happens is when you enter, this coil will connect straight through A to A, B to B, C to C, and this one connects A to A, B to C, and C to B. Basically just switches two lines, which is how you obviously reverse a three-phase motor. There's only one overload block on a forward reversing motor starter. That's not done because it's cheaper to put in one. It's done because if you happen to have two overload blocks and that motor was running in forward for a minute and then reverse for a few minutes and then forward for a few minutes, if they each had their own overload block, then the overload blocks would be cooling down. The forward block would cool down when the reverse block was conducting, and vice versa. We want all the current going to the motor to go through a single overload block so that we're actually correctly monitoring the amount of current and therefore the temperature of that motor. So one overload block. The overload heaters are here and they're in series with the motor because they need to see the full motor current. And then coming up on the side here, we've got our overload contacts, which are on a NEMA. Very rare to have a normally closed overload contact. These are all normally open. Some of the IECs have both a normally open and a normally closed. Generally, we use the normally closed even on an IEC just because they're more fail-safe. You can use the open one to run a trip light or something like that. So we got our two coils. We've got one overload block. Now, there's two bad things that can happen if both coils become energized at the same time. Number one, if none of the interlocking stuff was done and you energized both coils at the same time, you would get a phase-to-phase short. Whichever two lines you were switching the polarity of to get the motor to run in reverse would be a phase-to-phase short, and we all know that would be bad. So a forward reversing starter has to have a physical way of making sure that you can only pull in one coil at a time. And that's this set of bars right here, and it's called a mechanical interlock. So when we push in the reverse coil, you'll see this lever moved up, and that makes it so you physically can't move the other armature. And then once it drops back out, that arm comes down, and then the forward contactor could be pulled in. So the mechanical interlocks, they're there to prevent phase-to-phase shorts. It can happen that it's not only a matter of energizing both coils at the same time. These contacts can weld shut. I mean, it's an electrical contact. Over time, they can weld themselves shut. The return spring can fail. Various things can happen. So that mechanical interlock makes sure that this physical armature has moved out before it lets this armature pull in. And like I say, that's to prevent phase-to-phase shorts. The other thing you're going to see that's different on a forward reversing starter is compared to a normal starter is this auxiliary contact on the outside. So this is your reverse interlock contact, and this is your forward interlock contact. This is each of these are normally closed switches, and when the armature pulls in, this contact opens. And what that does is it makes it so that once the forward reverse coil, let's say, is energized, this is wired in series with the forward start circuit, and or the overall stop circuit, I should say, and that'll keep us from energizing that second coil when the first one's running. The reason for that is when these coils are first energized, the current will be fairly high, 4 or 5 amps, and then once the armature pulls in and that magnetic circuit is completed, the inductance goes up and the current drops down to like 0.5 amp. So if this coil was pulled in and we tried to energize this second coil, it would see a very high or reasonably high level of current because that magnetic circuit is broken, and that would cause the coil to burn out. Sorry. Had this tipped up just so it was a little more visible. So that's the forward reversing starter. It's got the regular normally open contacts right on the main armature, which are used for your holding contacts, the normally closed auxiliary contacts, which are used for electrical interlocks, the arms right here that block out the armature that allow only one armature to be pulled in at a time, a single overload block with a set of normally closed contacts. And that's all the pieces to a forward reversing motor starter.